Assalamualaikum and a very good morning to everyone. Let's join our Zoom meeting today. A kindly reminder to all of the participants, please be ready as our session will begin in a few minutes. In case of any lagging occurring on your side or our side, we apologize in advance for any difficulties on our behalf. To those who are here, please ensure that your microphones are muted and you are encouraged to turn on your cameras. Therefore, we will begin our Inside Talk for today at 10:05 a.m. Thank you so much. Welcome back, everyone. Good to see you again. Assalamualaikum and a very good morning. First, I would like to extend a very warm welcome to all of you for attending today's Sustain Our World Hybrid Camp. We appreciate you taking time off your busy schedules to join us today. We hope you will learn a lot as our committees has lined a fruitful and also exciting program for you today. I am Nuris Harnadi binti Yusri, together with Muhammad Alias bin Fosi, and we are from University Technology Mara UITM Shah Alam, and today we will be your MCs. Before we proceed, I have a few housekeeping notes with some details of our program today. First, please make sure your microphones are muted while the program is ongoing. And if you have any questions during the program, you may raise your hand and unmute yourself to ask a question or leave inquiries in the chat box to everyone or to me. Secondly, all participants are also encouraged to turn on your cameras during the program. And thirdly, please remember to switch your layout on the top right corner of your screen to the grid layout. Fourth, you are also encouraged to give your reactions during the program using the emojis at the bottom of your screen. And last but not least, please remember to fill in the attendance form provided at the end of this session in order to receive your e-certificate. Welcome to our first agenda for today. Inside Talk is a forum session where the panels will be discussing the topic of essentiality of industrial sustainability practices in reducing carbon footprint. Ladies and gentlemen, we are very grateful to have such professional panels gathered here today to share their expertise and also contribute to our collective understanding on the topic of essentiality of industrial sustainability practices in reducing carbon footprint. First, let us extend a very warm welcome to Professor Insigne Dr. Dominic Fu from the University of Nottingham. Next, we have Mr. Karthi Subramaniam from Desmet, Malaysia. Not to mention that we would also love to welcome Ms. Rachel Chok from Genting Biorefinery. And our fourth speaker is Mr. Eddy from Solarvest. Next, it is also my pleasure to introduce the chair of today's session, which is Insigne Dr. Chiu Juanjing. Dr. Chiu is the deputy head of School of Engineering and Science at Swinburne University of Technology, Sarawak. Dr. Chiu will explain to us the theme for today's session. And therefore, let's welcome Dr. Chiu for today's session. The stage is yours.
Thank you, Nani. Thank you, everyone, for coming to the sessions today. So, good morning. As Nani has introduced, I am Dr. Chiu. You may just address me as JJ, double J. So, other than being the deputy head in my institution, I also wear another hat. I'm the treasurer for the Palm Oil Processing Special Interest Group. So, Regarding today's topic, in my perspective as a global citizen of Earth, right, today's topic is highly relevant to all of us. So carbon footprint, we will actually be talking about the amount of greenhouse gases resulting from everyday activities from individual as well as economic. So like every individual, companies and manufacturing facilities also produce greenhouse gases during manufacturing, transportation, energy consumption and such. So there is a very delicate relationship between the businesses and the environment that can be both positive and negative. So on one hand, companies can positively impact the environment through their product and services. For example, the use of clean energy. I believe one of the speakers will speak further on this, and ways they enhance the conservation of natural resources. Promote sustainable practices. We have two speakers who will highlight a lot about this, how they make essential sustainability an essential component in their practices. On the other hand, business can also negatively impact the environment through their operations and supply chain. For example, the greenhouse gas emissions, pollutions, just to name a few. So I understand that we have many chemical engineering students amongst the audience today. So I hope that today's session will be an excellent opportunity for you to gain insight into the carbon reduction initiatives that has been done from the academic as well as the industrial perspective. So in the next few years, it will be decisive in our fight against climate change, and our success will certainly depend on our ability and yours to actually contribute to reduce our carbon footprint. So everyone has their part to do in this carbon cut. Okay, so I hope they can take this opportunity to learn how you as the future chemical engineer can play a role in this initiative. So we're honored and grateful to have today's lineup of panelists, and they will share their experience and insight for the first hour. After that, we will follow by 1 hour of Q&A after the presentation. So everyone in the audience, we invite you to post your questions via our Q&A platform Slido. The link can be found in the chat box at the bottom of your screen. You can also vote the questions posted by others. This will bring the questions up the priority list, okay? So without further ado, I'd like to invite Professor IR Dominic from Nottingham to share with us his presentation. The floor is yours, Prof.
Good morning, ladies and gentlemen. Guys, you need to let me share the screen. It doesn't allow me to share the screen yet. Okay, now it's fine. All right. Wish to confirm if you can see my slide.
Yes, we can.
Okay, good. Good morning, ladies and gentlemen. Well, good morning or good evening, wherever you are. Yeah, we have people calling in from Ireland like Oscar. So good very morning to you. Right. Today I'll talk about carbon footprint reduction for palm oil processing. Use a case study based on a refinery, but the principles stay the same for whatever chemical processes. If you are not working in palm oil processing, it doesn't matter because the concepts stay the same. So I'll talk to you briefly on some basic principle before I go into the palm oil case study. In the first place, let me sort of introduce to you the basic principle. When we talk about carbon footprint, this is the general term that we use in terms of CO2 content of any particular process or products. If you're talking about chemical products, okay, or generally consumer products, whatever the consumer receive, okay, that let's say we buy anything from the mall or from the market, the carbon footprint already has been abandoned into the products before it reached you. Okay, if you are looking from the perspective as a product supply chain, during the manufacturing of the products, we have the carbon footprint brought in from raw material. We have the carbon footprint coming in from electricity. We normally say these are external carbon footprint because you purchase the electricity from outside. Usually you will generate steam yourself, even though you purchase the fossil fuel from externally, but you generate the steam yourself within the company. So steam is considered as an internal footprint. So these have the carbon footprint brought in from internal parts, external parties, raw material, certainly from external. We add this carbon footprint to your products during the manufacturing process before it reaches the consumer. So you can say that if you want to work on for reduction of carbon footprint, we need to look at these aspects, okay, the internal part and the external part from material, from energy perspective. Now, in terms of scope, usually we say scope 1 of greenhouse gas emission. That is anything to do with the process that you generate within the company. Okay, and if you are talking about scope 2, this is usually referred to electricity, steam, heating, and cooling of your process. So scope 1 and 2 is something that we as manufacturers can do something about it in order to reduce the carbon footprint before it reaches a consumer. Now, on the other hand, scope 3 is relatively more difficult because you have to track the end use of the products, okay, or the supply chain, okay, or where the waste go, where all the capital goods and the upstream and downstream. So if you want to look at the low-hanging fruit, scope 1 and 2 are the usual one that you should focus on. Those are relatively straightforward, simple to keep track and for reduction. Now, there are some couple of papers that my team and I work on for the past decade or so. We started something 2010, which nobody bothered about carbon footprint, and then we went into more focus on it recent years. And you can see some of these papers. If you are keen, drop me an email. I can send to you as well. Now, principle is this: when we want to look at the hotspots, anything that has high carbon footprint intensity, we should focus on the reduction before we look at those with a lower carbon footprint intensity. You notice that this is a graph that I plot CO2 emission versus economics. The x-axis economics are things, the costs that you brought in the manufacturing process. Okay, any raw material that you purchase, utilities that you generate, or electricity you purchase come in with the costs, okay? And all these costs, apart from costs, you also have its carbon footprint. You can keep track the carbon footprint using some database or some basic principles to look at how much CO2 content on the materials or the utilities. In this graph, we plotted the external footprint versus internal footprint. The red line is the external footprint. Anything from outside, including your raw material, electricity, are the external footprint. Internal footprint is represented by the blue segment. Okay, this is usually referred to steam that you generate yourself or anything that you generate within your company. Okay, that is internal footprint. When you also notice the internal footprint has a higher, steeper slope compared to the external. Steeper slope means that per dollar and cents, okay, that you add to your product, you're adding higher carbon footprint to that particular segment. Okay, our principle is to look at the higher carbon footprint, and we try to do something about it. Okay, anything that high carbon footprint means that per dollar and cents, your CO2 content is higher. Okay, sometimes we have a target that we need to achieve. Sometimes we don't. Okay, it doesn't matter. In either scenario, you can have a intensity benchmark, okay, represented by the green line, okay. If that is the carbon intensity benchmark, we want to hit the carbon intensity benchmark by adjusting some internal processes in order to get it more efficient. For example, you can have power generation yourself through cogeneration or combined heat and power. You can also make use of renewable energy rather than relying everything from externally from TNB. So if for this particular case where the external footprint is lower intensity than the internal, meaning that we need to adjust the internal footprint so that it can hit the what we call the benchmark, okay, our target. So to reduce the carbon footprint, okay, we can focus on the internal footprint before we look at how to reduce carbon footprint from external party. Okay, this is one case. The other case can have a situation where the external footprint is higher intensity. You'll notice that the red line is steeper compared to the blue line. This also means that your material from your raw material, your utilities from outside has a higher carbon footprint compared to internal. So if you want to focus on external footprint reduction, you will have to reduce in the first place, if you're buying this from outside, it's difficult to change them unless you change the supplier. For example, you're buying a raw material from a party, unless you change a different supplier, or if you change the power supplier, like in many cases, you don't have a choice. Okay, if this is the only supplier you have, if it's the only TMB you have in Malaysia, then sorry, you're not going to change that. Okay, what you can do is reduce the dependency on these people. Okay, and that also means that you will reduce the costs purchasing material from them, reducing the electricity consumption, and then hoping that you will reduce the red line. Okay, the amount of the red line. Okay, you notice I reduce that length of the red line. The intensity stay the same, the slope stay the same, but then the length is reduced, means that you buy less from them, or you will have to cover it by yourself. Okay, by generating some steam yourself through heat recovery, through combined heat and power. If you can do that, you can reduce the overall carbon footprint to the benchmark that you're looking at. Okay, that's something that you can do. Okay, this is for the case where external has higher intensity compared to internal. Okay, these are the two general cases. Okay, let me also show you another situation where sometimes certain processes have multiple products. One process can generate several products, and you can see in this particular illustration, we have two raw materials coming in. They pass through processes A and B. And after that, it's split into process C and D. In process C, you are using power, and that generates product X. Process D, you will generate product Y by using some steam. So in other words, A and B is something what we call shared facilities, where they will have more than one products that pass through it. Processes C only generate product X product. Process D only generate product Y. This is what we call dedicated facilities. Okay, dedicated facilities is something that you need to be aware of if because it's only generate one single product. It doesn't have two products on it. Okay, for this kind of operation, we can also plot a similar diagram like I illustrated earlier. CO2 versus economics. Okay, this is the amount of money that you need to purchase for the shared facilities material, for example, electricity, and there's also a dedicated facility that you have to plot. If the shared facility have a higher intensity of carbon footprint, you'll notice that the slope is higher compared to dedicated facility. What we need to do is to reduce the intensity. Okay, try to reduce the intensity of the shared facility, or you reduce the dependency of it, so that you can bring down the intensity of the shared facilities. Okay, that will help you to reduce for both products X and Y. On the other hand, you can also have a situation where intensity of the dedicated facility is higher, means that the CO2 footprint, CO2 emission per dollar and cent is higher for dedicated facility. What you do is you will have to zoom in to processes C and D, trying to reduce intensity in order to bring down the overall carbon footprint. Okay, that's the illustration here. Okay, that's the general principles. Let me show you a case study based on these principles in a very recent paper. This paper just came on in these iChemie journals 2 weeks ago. Okay, if you are keen, you can go and download it. I think it's still for free for the moment. We have a case study built on to reduce the carbon intensity for edible oil refinery based on the case study over here in Malaysia. Okay, it was done by an undergraduate student of mine. Okay, so in this diagram, you can see a palm oil refining process. Okay, this is a very general, very commonly found physical refining. You have the what we call RBD palm oil that is being produced. Okay, RBD for students, if you're going into palm oil refinery, palm oil industry, this is something that you must know. RBD means refined, bleached, deodorized palm oil. In any refineries, physical refinery especially, you will have this RBD palm oil, and usually you have a side product, okay, a byproduct called palm fatty acid distillate, PFAD. Okay, within the refinery process, usually there are two sections: the bleaching and the deodorization section, and these sections have several units. Okay, the main important one is a bleaching section. There's a bleaching section here where you use low pressure steam. you will use some electricity, and because of that, you will have some CO2 emission. Okay, and of course, there will be pump in the process. There's a filter here. You notice that we are also generating some CO2 because steam usage. Anything to do with steam and power usage, there will be associated of CO2. If you want to calculate the CO2 footprint from power, our Malaysia power consumption is mainly fueled by coal and natural gas. So you just need to go to the literature and then do some search and look at the intensity per kilowatt of kilowatt of energy from fossil fuel, whether coal or natural gas. You will know how much is the carbon intensity. Very easy, straightforward calculation. Okay. If you need to know more, I can send you the paper as well. Okay. Now, down here in deodorization section, you have a deodorizer, and this deodorizer is a vacuum system. In order to run vacuum, you need motive steam. You need and then that also generated some CO2. You will have to have pumps. You can see that high pressure steam is needed in the heater. Low pressure steam is needed for the deodorizer. As long as you have steam, you have electricity, there will be CO2. Okay, you can calculate from that. From low pressure steam, high pressure steam, there are some index that you can use to calculate the carbon footprint. Okay, now then what we do is we plot the diagram CO2 versus economic value. Again, economic value are costs of making the product. Okay, you can see RBD palm oil here, the byproduct, palm fatty distillate. Okay, palm fatty acid distillate is byproduct. Okay, a big portion of the process is to make RBD palm oil. A small portion of that is to make the byproduct of PFAD. Both can be sold, and this product brought in carbon footprint. Okay, from the diagram earlier, you notice we keep track where the CO2 comes out from each of the operation, and then we can plot this CO2 versus economic value. And the diagram shows us that PFAD actually have a higher carbon footprint compared to the RBD palm oil. Okay, and what we need to do next is to look at the operation to see what option do we have in order to reduce the CO2 emission. Some of the options are quite obvious. You can do energy recovery. You can make clean energy, okay, clean fossil fuel, because we need to have steam usage. You can utilize some of the cleaner or greener energy sources to generate steam that will help you to reduce the CO2 emission. Okay, we put up a couple of scenarios. Scenario one is to improve energy recovery. At the moment, there are some energy recovery in the process already. If you notice, there's a hot stream coming out from the deodorizer column that pass through the two economizer before the RBD palm oil is produced. Okay, so well, I should say the RBD palm oil is already produced. The temperature is high enough. It passed through two economizer. This economizer is actually heat exchanger. Okay, you notice that 302 and 201. These two economizer or the heat exchanger help us to recover energy. However, they are running at the temperature, minimum approach temperature of 21.5. If you can reduce the delta T min, you will end up using less steam and using less coal utility or cooling water. Using less steam means that you will buy less fossil fuel. Using less cooling water means that you will pump less cooling water. Electricity usage can be reduced and CO2 can be reduced as well. Okay, so that is option number one. Option number two, we can make use of the very high temperature vapor pressure, vapor coming out from the deodorizer column. At the moment, is passing through, I think it's fed to the vacuum scrubber immediately, where it's mixed with PFAD recycle at 55 Celsius, where PFAD is produced as a byproduct. Now, feeding a high temperature stream with a low temperature non-isothermal mixing is actually a waste of energy. So one option is to pass it through a heat exchanger, lower down the temperature before it's fed to the vacuum scrubber. And doing this help us to raise steam. Okay, you can put in water. You still need a pump to increase the pressure. This is also still emitting CO2 when you have a pump where electricity is used. But when you generate steam, the steam can be used to reduce the steam that we need to generate using fossil fuel. So that helps to reduce CO2. Okay, this is the second option. Option number 3, we can make use of biomass. Okay, because for palm oil refinery, usually many of the refineries are located near the palm oil mills, and especially for companies that owns both the mills and the refinery, sourcing the biomass from the mill is easy. Okay, you just need to give a call to the mill manager, ask him to send you some biomass. Okay, it can be a fiber, palm fiber, can be PKS. If they want to sell the PKS to you, they can do so. If you can carbon the either the PKS or the palm fiber with the fossil fuel, okay, you still have to purchase some fossil fuel, definitely. You can see that if you mix 5%, 10%, all the way to 50%, the CO2 emission will be reduced, definitely. Okay, this is given by the green color line. You can see that the green line is dropping, CO2 emission is dropping. However, you will have to do some retrofit on your boiler. You need to modify the boiler. If you're buying solid biomass from the mill, you will have to gasify them before you can mix with your natural gas boiler. If you're buying the what do you call that, the fiber, you still need to modify your boiler a bit. Okay, so it depends on what the facility you have. Okay, but more biomass that you buy, more modifications are needed, and you will notice that the retrofit costs raise. Okay, given by the blue bar, these are the costs that you need to incur to modify your existing facilities. Okay, in order to make your process greener. Nothing is free. Okay, everything come with some kind of investment. Even you ask them to send you the biomass, they say I'll give you for free. You will still have to send your lorry. Your lorry still run on diesel. Your diesel still make CO2 emission. So it's a matter of finding a trade-off among all these scenarios and the options that you have. Okay, I don't have time to go to the details, but what you can do is to plot out the scenarios in the diagram like this to see how much retrofit costs you incur. Hey, by the way, the good news is sometimes you get a saving. Okay, for some of the options. Some of the time the retrofit cost is positive. Some of the time retrofit cost is negative, meaning that you actually have a saving. Okay, by running some of the options, and then you can see the CO2 reduction, okay, accordingly. Okay, usually more money that you invest, more CO2 reduction you gain. Okay, but it could be the other way around as well. Okay, depending on the option, depending on the plan, depending on the data, and depending on how you deal with the options that you have. Okay. All right. I think that's the basic the case study I want to show you. Fortunately, we are bound with the time. Finally, I would encourage you to get a copy of some of these books. The two that I edited lately, one was during the lockdown. Okay, the good thing about lockdown is you have time to write books. How to make use of the diagram that I show you to plan for CO2 reduction, the first book on the left, and this one on the right hand side with the orange color cover page is very recent. It just arrived me actually 3-4 a week ago. Okay, I don't know if you can't see it. Okay, this is the book that talk about some of the sustainable process technologies, sustainable technologies for palm oil industry. Okay, contributed by various people in the industry. Okay, people from the industry as well as from academia. Okay, and I believe some of them are the POPSIG committee as well. Okay, those are the content of the book, mainly on palm oil mass and palm oil processing. Right, that's my salesman talk. Okay, if you are keen to explore options to do decarbonization, feel free to talk to me. Okay. Oh, by the way, the picture is in the office. I'm now talking to you from my home office. Okay. All right, my email is there. I should stop now. If you have questions, you may ask, or else I'll pass to the next speaker. All right, JJ, pass back to you.
Okay, thanks, Prof. Dominic. So I guess next we can invite our next speaker, Mr. Karthi, to start his presentation. The questions we'll leave until the Q&A sessions. Thanks, Prof. Mr. Karthi, over to you.
Thanks, bye. Unfortunately, I need to leave. If there's any questions, drop me by email, it's fine.
Ken, no problem. We'll communicate it. Thanks, Prof. Dominic.
Welcome.
Be able to see the screen now?
Yes, we can see your screen, Mr. Karthi.
Okay. Good morning, everyone. I thank IKME and POPSIG for inviting me to speak in this event. So today I'm going to speak about the process solutions for reducing carbon footprint. So myself, Karthi, I'm working as a senior process engineer, oleochemicals in Desmet, Malaysia. So today I'm going to speak about the first small introduction about the company, then a briefing about carbon footprint, and the main focus which is on the process solutions to reduce the carbon footprint, which I'm going to touch about the optimization of a few topics like chemical consumption, electrical consumption, utility consumption, and other few initiatives outside the plant but inside the premises for reducing the carbon footprint. Desmet Group is a world leader in developing, engineering, and supplying technologies, process plants, and proprietary equipment, mainly in food feeds and biofuels, oil fat processing, oil sheet pressing, and animal byproduct from the oil seeds and food feed milling. So there are about 1,200 employees in our company, and we have offices spread in various parts of the globe. And in Southeast Asia, we have offices in Malaysia, Singapore, and Indonesia. We also have a R&D team, R&D office, R&D centers in Italy, Belgium, and recently last week we have inaugurated a global R&D center in our Malaysia office. Okay. Now, just I would like to give a brief, very brief introduction about carbon footprint. So the carbon footprint basically means the total carbon emissions by a single entity or a person or product. So the carbon footprint of a person, organization, or object can be assessed on the basis of emission of greenhouse gases such as carbon dioxide and other gases. In other words, carbon footprint is the total amount of carbon dioxide and other greenhouse gases that are exerted throughout life cycle of any product or a service. So the carbon footprint have a negative impact on the environment in multiple ways. It is the main cause of human-induced climate change. It contributes to the urban air pollution, leads to toxic acid rain, and adds to coastal and ocean acidification. Also worsens the melting of glaciers and polar ice. As a result, there is a drastic chemical change, marine life depletion of natural resources, and habitat destruction. So, it is a responsibility of every individual to take small steps to reduce the carbon footprint, if not to achieve zero carbon footprint. So, okay, so edible oil industry plays a major role in the supply chain of the vegetable oil and its products. So this edible oil industry plays a significant role in the carbon footprint in the overall map, if we see. So it is essential to take take steps to reduce the carbon footprint. Also, at the same time, in an efficient way, so that there is no major cost involved in the process. So inside an edible oil refinery or an edible oil process plant, the main focus is reduction of the consumables. Either it can be chemical consumption or electrical consumption or utility consumption. So focusing on these things will also be to just brief you some case studies. First is regarding the optimization of or reduction of chemical consumption. So here you can see a process flow diagram of a conventional neutralization of oil, like soybean oil using caustic soda. So here in a typical neutralizing line, the oil is treated with acid in order to make the gums more soluble in water. And then alkali is added to neutralize the free fatty acid in the oil, and also to neutralize the mineral acid which we added for degumming. So typically we add about 0.7 to 1 kg per ton of phosphoric acid. We add around 1.5 to 1.7 kg per percentage of free fatty acid present in the crude oil, and 1 kg per kg of phosphoric acid added upstream. So this is the typical consumption figures. Okay, this is a typical sketch of a typical PFD of neutralization. This process, if you see, the crude oil will be heated from 30 degree to 95 degree, and we add phosphoric acid, and retention time of 20 minutes will be given. And then we add caustic soda, and further retention time will be given for reaction. But there are number of permutation and combination which we will not go into now. We will concentrate only on the chemical consumption. So recently we have introduced a new technology called nano neutralization, where the nanotechnology is a new approach that brings the reactant together at the molecular level. Because I'll just go to my previous slide. We can see the chemical added here is 1 kg per 1000 kg of oil. So there is a huge difference between the quantity of acid added and the quantity of the oil. So it needs an effort for the acid to go and reach each molecule of the oil. So by enhancing the creating a reaction environment to help the acid to reach the molecular level, will increase the efficiency of the reaction. So, so in nanoreactor, the oil and the chemical reagents are forced at high pressure. So the nanoreactor operates at very high pressure, and it passes through the mixture of oil and the chemicals passes through multiple cavitations of it's like a high shear dynamic static mixture. Actually, it's a high shear static mixture actually, where the oil and the chemicals are pumped at very high pressure. So so in nanoreactor, the oil and phosphatides form tiny droplets called micelles, which are very hard to break up. So the cavitation is sufficiently powerful. The cavitation created inside the nanoreactor is sufficiently powerful to disrupt these micelles and bring the reactants into contact with the components. So as a result, what is achieved is, instead of 1 kg per ton of oil, only 0.2 kg per ton of oil is sufficient. And the caustic consumption reduces from 1.7 to 1.43 kg per percentage of FFA, and this 1 kg per kg of the acid remains same. But in reality, this also comes down because we are adding only 0.2 kg of acid per ton of oil. So this results in appreciable reduction in chemical consumption. And this is not only reducing the chemical consumption here, because in neutralization, when the free fatty acids are neutralized by the alkali, soap stock will be formed. So this soap stock contains the soaps and also the salts of the salts of this acid and alkali. So these needs to be treated with a strong acid to form, to convert into acid oil, which can be further processed. So because of the less consumption of the caustic and also less consumption of the acid, the quantity of soap stock generated is also reduced actually. So the treatment of soap stock is a simple process, but it's a bit tricky one, and we need to use concentrated sulfuric acid, and the MOCs involved in this process are it needs to be highly resistant to the acid. So the reduction in soap stock quantity is also seen as a favorable outcome of this implementation. So this nano reactor is an add-on one. It's like this part can be added to any of the existing plant. And in recent past, number of units have been supplied and it's been running successfully. This is specifically successful in neutralization of soybean oil actually. So here we can see some data. It is taken from 400 TPD nano neutralization of soybean oil. So the consumption of phosphoric acid is 0.2 kg per ton in nano neutralization, whereas in caustic refining it's up to 1 kg per ton. And FFA for caustic for neutralizing FFA is 1.43 kg per ton, whereas in conventional neutralization, it's 1.55 to 1.7 kg per percentage of FFA. And NaOH required for neutralizing the acid, what we have added is 1 kg per kg of phosphoric acid added. Here, this phosphoric acid, what we are adding is multiple times more than the stoichiometric requirement. Because of the less reactivity of this phosphoric acid with the gums. Hence, most of the, approximately about 90% of the phosphoric acid remains unreacted. So this needs to be neutralized. That is the reason we are adding the caustic to neutralize this phosphoric acid. So if you see the quality of the refined oil, still there is also improvement in the quality also. So this is an added advantage, but the main advantage what we see here is the reduction in the chemical consumption. So in a nutshell, if you see the phosphoric acid saving for this capacity and the rate of 0.8 kg per ton dosage difference, like 1 minus 0.2, 0.8 will be 320 kg of phosphoric acid per day, and caustic soda will be 379 kg per day. So and this is calculated based on the dosage displayed here. So I would also like to share a small costing which I worked out a long time back. The figures here are in Indian rupees, since I worked this out some time back when I was in India, and we are making this costing for a client. So here we have given the costings of crude oil and the byproduct and the chemicals and the electricity and the acid oil processing cost, and further silica added in the downstream. There is a saving in the silica added in the downstream also, because of the very less content of soap in the neutralized oil. The consumption of silica in the downstream process is also coming down. So that is also included in the costing factor. So for nominal 300 days working operation per year, and if we consider all the factors, and here we have given the dosage parameters also, so the quantity of phosphoric acid dose in conventional and in nano, also the caustic consumption in conventional nano, and silica consumption in the conventional bleaching and nano, and the electrical consumption. So electrical, there will be an additional consumption here, because we are using high pressure pump at 60 bar gauge. So that will be an added cost for this. So overall, there will be a saving of around 39,000 Indian rupees per day, which accounts to 11 million Indian rupees per day. So this is approximately around 65,000 RM, I can say. Yes, it's around 65,000 ringgits per year. No, 600,000, sorry. So 600,000 ringgits per year. So this is the saving, but the focus, since we are talking about the carbon footprint reduction, so we can see the quantity of the chemicals reduced here. And also this is done in a manner where we can also expect a reduction in the operating cost. So this is related to the chemical consumption, and the next is the electrical consumption. So here it's a typical PNID of a clean cooling tower. So the clean cooling tower, if we are using in a place where there is a difference in climate, like in winter season, if we have a winter season or summer season, rainy season in a place like India. So in summer, we need to operate the cooling tower fan at full capacity. But whereas in rainy and winter season, in the night time or in times when the night time the atmospheric temperature is less, it is not necessary to operate the clean cooling tower fan completely. So the clean cooling tower for a plant is the fan of the clean cooling tower will be having a bigger motor, and the consumption will be appreciable compared to the overall consumption of the plant in general. So if we provide inverter, if we add an inverter to the clean cooling inverter to the motor of the cooling tower fan and control with the outlet temperature of the water, then there will be an appreciable saving in the electricity. So this we have proposed to, we propose to all the clients, and many clients have implemented it, and we have noticed appreciable savings in the electricity. Then the clean cooling tower motors, pumps also will be of very big capacity in the range of like 800 meter cube per hour, 400 meter cube per hour. And in the clean cooling tower pump, always there will be a design case and operating case. So design case will be at least 1.5 to 1.4 times more than the operating case. So throughout the year, the pump will be run at operating case, whereas during shutdown or startup, the cooling tower pump will be operated at the design case. So it will also be a good idea to put an inverter for the clean cooling tower pump to run the motor at low speed, which will result in an appreciable saving of electricity. Even without the inverter, this pump can operate because each and every individual process consumers will have its own control valve, and it will throttle the flow. And there will be normally there will be a recirculation a bypass to the process section. So as such, the cooling tower pump will run, but it will always consume higher energy. But putting an inverter and running at lower speed by maintaining a constant pressure at the outlet will definitely result in a higher, lower electrical consumption. Then another aspect of electricity conversion is that each and every pump, like this is a conventional pump where it transfers a product from a final vessel to storage, passing through a heat exchanger. So typically the flow will be controlled either with the flow control or with the level control of the vessel using a control valve. But again, using a control valve the control valve, normally we design the control valve to operate at 60% or 70% opening, which means that it is throttled for 30 or 40%, which gives additional pressure drop to pump and results in higher electrical consumption. But at the same time, instead of control valve, if we use inverter and remove the control and use the flow control using the inverter, it results in power consumption. I'll show you for all these scenarios. I will show you an actual example we did in the recent project. You can see this is a curve of a pump where the design case is the pump curve for the design case is this one, and the flow rate at the design capacity is 350 meter cube per hour. But the normal operating capacity is around 150 meter cube per hour. So there is a big difference here. Okay. So there are two options. Either we can put two pumps. So during normal operation, they can use only one pump, and during shutdown case, they can use two pumps together to achieve this thing. But if you want to use only one pump and don't want to put two pumps, then we had asked the vendor to re-rate this pump for the lower capacity using lower motor speed. So this is the pump curve for at lower motor speed 1086 RPM. So here you can see the power consumption. It's around 15 kilowatts, whereas at the rated capacity it's 38 kilowatts. So there is a big difference in power consumption. So this is the actual example of using inverter in the places where the flow rate is very big, and there is a big difference between the design and the actual flow. So we always propose to all our clients to use inverter wherever we have a control, flow control or level control in the downstream of a pump, instead of using a control valve. There will be a small increase in capital cost instead of using control valve by using inverter, but definitely it will be in a long term the cost will be paid back because of the reduced power consumption. Also, using the motor, while using motor, the selection needs to be done properly. Recently, we always propose to use IE3 category motor, where before like 5 to 6 years, IE2 was commonly used. IE3 motors always have high efficiency compared to the IE2 motors. So there will be a bit of increase in cost, but definitely because of the difference in efficiency, the power consumption is always low in IE3 compared to the IE2 motors. So this is related to the electrical consumption. Then I think Mr. Dominic explained, has shown a much better picture than this. But this is a very, very simple basic block diagram of bleaching and DO section. So here, here in any process plant, as a process plant supplier, our intention is always to minimize the consumption of heating medium and cooling medium, which means to reuse the energy generated inside the plant itself. So here you can see the crude oil in the bleaching section, which comes at 50 degree, needs to be heated up to 100 to 105 degrees Celsius for bleaching process. And then the bleached oil needs to be heated from 100 to 105 degrees Celsius to 260 degree in deodorizer. So this 260 degree deodorized oil, before sending to storage, should be cooled down to 60 degrees Celsius. So this temperature difference of 200 degrees Celsius needs to be recovered within the plant. So all our efforts, and I believe that, all the process plant suppliers, they will we are continuously improvising and make all of our efforts to improvise this heat recovery. So the type of heat recovery and the heat exchangers used for heat recovery is continuously evolving. We employ various types of heat exchangers like spiral heat exchangers and plate heat exchangers, shell and tube heat exchangers, multiple stages of heat exchangers to improvise the heat recovered from the hot oil to the cold feed oil. So previously Mr. Dominic gave an important value that the approach should be reduced as much as possible to 20 degrees Celsius. So here we can see it's now it is at 40 degrees Celsius, 90 degree and 50 degree. The approach is around 40 degrees Celsius. So if we go up to 20 degree and less than 20 degree, then it will be then we'll be in much better position. So that's where all our efforts are going on. So this is one typical example of heat recovery used inside the process plant. And there is one important point which is never explored in our process, in our industry, that to use the heat energy of PFAD vapors generated inside the deodorizer. That was one important point highlighted by Mr. Dominic. That is very interesting, and it will be really nice to explore more on that. Actually, it's a bit difficult. I will not say it is a bit difficult, but it has been never explored so far to extract the heat from the PFAD vapor, because the PFAD vapor will also be at 260 degrees Celsius, and it has appreciable amount of heat. So it is an interesting point. So next is condensate recovery. So condensate recovery is recovering the heat energy inside the steam condensates. So it is typical example of condensate recovery section. So where the HP high pressure condensates from process is flashed in a condensate vessel where it generates the medium pressure steam and medium pressure condensate, whereas in turn the medium pressure steam is flashed in a flash vessel to generate low pressure steam and low pressure condensate. So this effectively recovers all the energy in the HP condensate than directly sending it to the boiler house or directly flashing into the atmospheric pressure. So the configuration of this condensate recovery system can be customized as per the condensate available in the process plant. So if you don't have a HP condensate, we have only MP condensate, then we can generate LP steam from the MP condensate. So it varies from plant to plant, but this condensate recovery system should be implemented in every process plant in order to recover all the energy available in the condensate. And further, this LP condensate can also be flashed to atmospheric steam or with low pressure, very low pressure steam, where those steam can be used in tank farm heating and other applications. So these are the points which I wanted to share regarding the improvements in process that can be made to reduce the carbon footprint. And some other points which I would like to highlight is that I read in recently in a paper that a case study where changing all the lighting system in a plant premises to LED bulbs resulted in appreciable savings in electrical energy. And this is also one of the sorry, this is also one of the points which can be considered, and creating a green zone inside the plant premises which can absorb the carbon dioxide. And recently I also learned about capturing the emissions from the vent emission systems. That is also one of the it is not subject of our expertise, but it is outside battery limit subject, but this also can be implemented in inside a process plant. So okay, I think I took a little bit of extra time. Sorry for that, but thank you very much for attention of everyone. I remain for any questions.
Okay, thank you so much, Mr. Karthi Subramaniam. Also joining us today is from the Genting Biorefinery, and therefore, without further ado, we would invite Mr. Chok to start his sharing session.
Sorry, I just unmute. Okay, good morning, everyone. So today I'll be sharing on what we are currently doing in a biodiesel production, since I'm working in a biodiesel plant. So let's start it for a while. So why are we doing carbon reduction? So it's in apart from being a promise, being a global thing, actually Malaysia had already submitted our revised NDC on the National Determined Contribution, our revised one, in July 2021 to actually reduce our CO2 emission by 45% in the year 2030 compared to 2005. This was actually revised previously and increased 10% from previous committed of 35%. So based on a report released by KPMG, in I think this one in 2021, if I'm not mistaken. So Malaysia is actually placed on in the 21st place for net zero readiness index on the net zero readiness index. In terms of being sector wise, we are actually in the same place, 21st. So this report actually focuses on the progress of each countries in reducing our effort in reducing GHGs and assess our preparedness and our ability to achieve net zero by the year of 2050. So Malaysia being 21st among, I think, 30 countries makes us actually the 5th among the Asian countries after China and South Korea, etc. So if you can see here, based on the 5 highest emission sectors, industry actually is the 3rd largest emission contributor after electricity and agriculture. So, and then in terms of maturity for our preparedness is actually below the what we call the passing rate lah. It's actually below 50%. So moving on our typical biodiesel production, what you can see here is that for the refined palm oil, RBDPO, we are going to feed it into our plant to go through a trans-esterification process. We use methanol as our chemical, and then for most processes, we are using sodium methylate as our catalyst. With the usage of steams and water, then we'll produce what we call crude biodiesel and then unrefined crude glycerin, which both will be going through another purification to remove mostly methanol and water, etc. So in this process, actually, we recover the methanol to be reused back in our trans-esterification processes. So at the end of the day, we'll get biodiesel and refined crude glycerin. So today I'll be mainly talking about how can we reduce our carbon footprints in terms of as a processing unit itself. So actually my plant, the current plant that I'm working in with, we are situated in Ladatu, which we are in the industrial park. So the good thing about industrial park is that we have a variety of different processing units just nearby us. So by this one, by the location of our plant, we are able to reduce the carbon footprint in terms of delivery of our raw materials and our products. For example, I just do a quick calculation that day. So in terms of raw materials for our refined palm oil, that we are actually getting it from just nearby 2 refineries nearby within a radius of 1 kilometer. The GHG emission that we are able to achieve will be 0.13 kilogram CO2 per metric ton of feedstock versus a road tankers, let's say, just this one is based on 1 kilometer, is 0.14. So the 0.01 kilogram of CO2, it seems to be very minimum, but then if we are calculating based on per kilometer that we are traveling, let's say we are traveling let's say 50 kilometers apart. So this one will be much more significant in terms of receiving of raw material. So in another thing that we just recently do in this 2 or 3 years is our receiving of our chemicals in terms of methanol in vessel. So we are importing it from Labuan. So the GHG emission will be 44.1 kilogram per metric ton of methanol that we imported versus the road tankers that we're using, because we need to travel the raw material we need to send to Sandakan and then travel here by road. So that one is emitting around 48.4 kilograms. So that's a saving of 4 kilograms CO2 per metric ton of methanol. Moving on, just now I think Prof. Dominic and Karthi had already mentioned that utilities play a big part in terms of processing, that it eat up a lot of this kind of emitted a lot of CO2. So in terms of how we run our production is that we try to consolidate our production into a single one, a better planning so that we can minimize our energy consumption. So in this case, for every single startup we'll use for boiler steam generation wise, we need around 3 tons of diesel. So this one plus all the utilities of electricity consumption, actually this one we can save around 3,500 3.5 ton of CO2 emission. And then alternative electricity and energy source, in a sense that what Dominic had mentioned just now, is the usage of biomass boiler. That one will eventually help a lot in terms of bringing down the total GHG emission. So in terms of process, for our process of transesterification and the purification of our products, so we have tried to go into every stream of our process, that we try to eliminate the unnecessary chemicals or processes. For example, in the esterification, that we actually eliminated the usage of sulfuric acid. And then for the heating and cooling, that when it's unnecessary, we'll just eliminate it, so we can save in terms of electricity and the steam consumption. So in terms of process optimization, I think every single production, it's good to look at optimization so that we don't waste things that we don't need in terms of in terms of raw materials and energy. So for biodiesel production, the main GHG emission actually comes from usage of methanol. It contributed around 47% of our total GHG emission for our biodiesel plant. So from this point, after some upgrading work that we have done in the plant, we are able to maximize our recovery of unreacted methanol, which this one is equivalent to around 30 kilogram of CO2 GHG per metric ton of feedstock. In terms of tonnage, should be around per ton of RBDPO feed, we're saving around I think let me back to the numbers. But then this one, in terms of dollars and cents, this is able to get us with the plant design capacity. It will be able to save us around 4 million per year. So in terms of our catalyst, because it's esterification, transesterification process, chemical reaction, in terms we can further fine tune our sodium metallate consumption, which this will further bring down our GHG emission. Heat integration, in terms that we are already starting, we have designed modified our steam condensate discharge, that we actually recover that, and then we use back as a boiler feed water, which that decrease our consumption for our fuel, and then it further optimize our steam utilization. And then on the efficiency of our process equipment and the equipment's material compatibility, this is mainly looking on how suitable are the equipment and their materials, because biodiesel actually does do a lot of they do corrode a lot of stuff. So this is in terms of how we carefully choose our material compatibility, so that they'll have a longer lifespan. So, and then on the process improvement, we are let me get back. So we are going to look, moving forward, we need to look on the adaptation of our existing processes for the usage of alternative feedstocks, which currently is being quite a hot issue in terms of usage of used cooking oil as our feedstock in terms of second generation feedstock, waste oils and fats, and then on biomass. And then further upgrading of existing process equipment that we can further bring back, because technology 10 years ago and technology nowadays will be different. So in terms of efficiency, it will be much higher for the current latest equipment. So on the effect side, why are we doing so much in terms of why do we need to do so much? In terms of environmental, I took all this from the SDGs, the Sustainable Development Goals, that in order to make our world a better place, we should focus on the responsible consumption and production, and then so that we can do our part in terms of climate action, in terms of global warming, we can do a part of it. And then in terms of economical, by doing upgrading and then the adaptation of our processes and modification, it doesn't just look good on our carbon emission profile, but it will also contribute to some cost savings, and in turn we are actually creating much more job opportunities for other people. In terms of social, once there's job opportunities, then we can achieve our goals in terms of poverty, our hunger, in terms of social, reducing inequalities and good health and well-being. So that ends my presentation. I'll pass it back to JJ or Nani.
All right, thank you so much, Ms. Rachel Chok, for your sharing session. Next, our fourth speaker is Mr. Eddy Lee from Solarvest. Moving on, Mr. Eddy Lee, you may start your session now.
Thank you, Nani. I would share my screen. All right, good morning to everyone here. So I represent Solarvest Holdings Berhad. We are actually a solar renewable energy company. So today my topic is moving towards clean energy. So I will give you a bit of different perspective from a solar energy standpoint. How do we see the clean energy market? And perhaps there's some relation to the previous speakers as well about the palm oil industry. So a brief introduction about Solarvest Holding Berhad. We are actually a listed company in Bursa, Malaysia. We are actually a 10-year-old company. We have offices in Penang, Selangor, and Johor. We have global presence as well in several Southeast Asian countries. And we currently have an installed capacity of solar energy, 400 megawatt peak around Malaysia, most of them. And these are the following are the industry accreditations specifically for solar industry. So Solarvest, we actually have transformed ourselves from a pure play solar company to become a clean energy specialist. Why do we have these transformations? As you all know, we're all moving towards clean energy trends. You might heard of ESG, environmental, social, and governance, as presented by the other speakers. ESG is a hot topic nowadays, driven from, I think, from the West, Europe, US, then it comes into the Asia, and a lot of countries has actually announced their net zero goals. So clean energy or renewable energy like solar, wind, biogas, biomass are not enough basically to meet the ESG goals of a country or of a company. That's why in order to move towards the direction of becoming a net zero country or for a company to become a net zero carbon target, there's a need to look into different kind of clean energy solutions other than just the renewables. So here we are talking about something like electric vehicles, the electrification of the transport industries. We also talk about storage of energy. Once you generate the energy from the renewables, how do you store this energy so that you can use this energy, for example, at night when the solar is not out and running? Or for example, if there's no hydro, for example, if there's no biogas in your area, how can you still store the energy from somewhere else and localize and energize and power up the houses or the offices in that particular communities? Hydrogen, I believe all of you had heard about hydrogen. Hydrogen is not just, at the moment, is maybe a feedstock or perhaps one of the materials for industrial processing. In the future, hydrogen can also become an energy carrier for use in transport or to be used to power energy or generate electricity as well. Energy efficiency, just now a lot of speakers have talked about how to optimize the processes, palm oil processes, oleochemical processes. So all these processes will require less energy. We need to reduce energy to meet our net zero target of the company. So energy efficiency is also a very key topic when we talk about clean energy ecosystems. And last but not the least is green data center. Green data center again is in drive with the digital transformation of every country. We talk about 5G adoptions in our country. We talk about AI, IoT. All these will require data center behind the scene. And data center, as you all know, it consumes a lot of energy actually, because of the servers running 24/7. So there's a need also to transform and electrify, make this green data center become as green as possible. So this is actually a nutshell of what I have presented just now. When we look at energy value chain, right, we have to look from upstream to downstream. Upstream is what we call as how you generate the electricity or the energy. For example, solar, for example, biogas, biomass, wind, all these are generations. After that, you need to transport this energy that you have generated to the consumer or to the end user. And that's where we call it transmission, distributions. 80% of the time, how energy is transported is through electricity, through the grid, the TNB, Tenaga National Grid. They have transmission grid and then they have distribution grid. Moving forward, there will be other forms of transmission or distribution, like I talk about battery. Battery, you store the energy, you can bring the battery from one place to the other rather than rely on the grid itself. Number 3, energy as a service. This is actually a buzzword. It basically means how do you consume the energy that you have received from the generation or from the storage? Do you use it in the cars? Do you use electricity rather than petrol or diesel, for example? You change to electric cars, or the way you consume energy in your environment, in your day-to-day life. Perhaps I should reduce the consumption of aircon in my houses, or perhaps I should change my LED lights, change my house lights from fluorescence to LED to save more energies. So all these are called energy as a service. And last but not the least is the energy tech. All this will require some digital involvement. Energy is also part of the industry where we have a lot of influence or even impact from IR 4.0, for example, artificial intelligence, Internet of Things. All these are also applied in the energy industry as we transform our energy industry from a centralized market to a decentralized market where everyone can receive energy the closest as possible at their source. Meaning to say, now we receive energy from maybe a source which is a bit far away, like a power plant, which we might not be able to see. But I can tell you that in the future, energy will be a decentralized industry where all of us will have a chance to receive the energy as close as possible to the source. So I'd like to explain first about the solar market. Solar, as you all know, is actually the largest renewable method in Malaysia at the moment. Currently, we have around 3 gigawatt of solar already installed in Malaysia. And upcoming, we're going to reach 5 to 6 gigawatt in 2025 in less than 2 years' time. So where are the solar panels or where are the solar systems that you would have seen in Malaysia? There are 3 areas where you can find our solar systems. First is large-scale solars. These are big ground-mounted solar that you usually find in, I would say, in rural areas or in areas where usually is 10 acre, 20 acre of a piece of land. So this is usually you're unable to see in the urban area. You will see off the highways, perhaps in Perak, in Kedah, or in Penang. Okay, maybe some in Malacca, some in Johor as well. So these are large scale solar with ground-mounted systems, usually on the ground, and some might be on the lake, like in Dengkil. There's actually a floating solar of 12 megawatt size. If you have the chance, you can go and have a look. Then the second segment is called commercial industrial. This is what we call as rooftop solar systems. So the people who adopt solar the most are actually those who consume the most energy. So having said that, is usually the factories and the commercial malls, or sometimes this entity usually have large rooftop surfaces. I give you an example. Anyone of you know Tesco? So Tesco have maybe 50 to 60 stores throughout Malaysia. They have rebranded themselves, become Lotus. So Lotus had actually a target to solarize all their buildings in Malaysia by within 2 or 3 years' time. So, for example, if you go to the Lotus, very high chance that you will see on their rooftop is already putting on the solar panels, and that solar energy will straight away be consumed by Lotus themselves to offset the energy or electricity used from the grid instead. Number 3, residential. Yes, this is your houses. Condos, I would say not much, because condos, usually the roof surface is really limited. You cannot put as much solar as you wanted. And the rooftop size is also so limited that maybe if in a condo, 200, 300 units of people might not be able to benefit from the solar energy. So here, residential, most of the time we talk about landed houses. So landed houses, yes, you can also put on the solar system. For example, if your TNB bill at your house is 400 ringgit, 500 ringgit, once you put on the solar system, straight away it offset the electricity that you consume from the grid, and your bill might be half, or even you might save perhaps up to 90% for certain houses that install the max of the solar system on their rooftop. So other than solar, just now, the first speaker also talked about Scope 2, Scope 1, and Scope 3 emissions. For a country to reach net zero, we need to look into all these three scopes. For a company or a corporate who want to go net zero, they all have to look into Scope 1, Scope 2, and Scope 3 emissions. And for Scope 2 emissions, particularly, which is the energy consumptions, we usually look at how to adopt renewables. And for those who don't have the roof, perhaps, or even enough power that you purchase from the solar companies, usually you can purchase certificates. Certificates are called green attributes that you can purchase from anywhere, and you can use that certificates to offset your so-called energy consumption, so that you assure that your energy that you declare is all clean and green. Carbon credits. Carbon credits are mostly for Scope 1 and Scope 3 emissions. Scope 1 here is direct carbon emissions from your processes, from your company activities. Scope 3 here, we are referring to emissions from, not from yourself, from either your customers, your suppliers, or your other stakeholders. So in that case, when they want to claim they are net carbon zero, usually either they reduce the carbon emission at their premises. If they can't, they have to consider to purchase carbon credits. Carbon credits will offset the carbon emission that you emit in your processes. And in the end, the company per se is able to claim a net zero as its target. Another topic that we can perhaps think about is green mobility. Actually, this month is actually a very interesting month because we call it the month of electric vehicles. Why? Because there's a lot of events ongoing. Not sure if you all have attended the Future of Mobility or the Automotive Roadshow in early of the month in Sedang. So the big topic on that roadshow is actually electric vehicles. So electric vehicles in Malaysia at the moment, there's around 30,000 plus, including hybrids. Full electric, perhaps 2,000 to 3,000 on the road. Yes, it's not a lot. You might heard of Tesla, you might heard of BYD. Those are some of the cars that have already imported into Malaysia. So this is some of the landscape of the Malaysia electric mobility market. Government has introduced a lot of policy in the last 2 to 3 years, especially to speed up the EV adoptions among the rakyat of Malaysia. So some of the policy that you have seen, the latest one is the 12th Malaysia Plan, or the National Energy Policy 2022 to 2040. There's a lot of EV related policy coming out that spur consumers or even spur the manufacturers to assemble electric vehicles here in Malaysia so that the people here can afford a cheaper EV at the moment. Here are some of the Malaysia numbers in terms of EV market. In terms of EV cars, yes, actually, if you include all type of electric vehicles here, perhaps on the road, you can see more than 100,000. Out of 10 million cars on the road, let's say 1% of the car is electric vehicles. And out of this 1%, right, 100,000, you will be surprised that actually the full electric is only less than 3,000 or 4,000. So that shows that a lot of people still driving hybrid cars, but hybrids are not totally electric vehicles. So it's something that we have to familiarize with, the different definition of electric vehicle in the market. When you buy electric vehicle or when you want to go for this kind of initiative, the first thing you will think about is, how do I charge my car? Where do I charge my car? And how much I need to charge my car? So all these are very valid questions when a consumer wants to shift from the current engine car, petrol engine car, or to an electric vehicle. So in Malaysia, there's actually already 900 charging stations in the whole Malaysia. In Klang Valley itself, maybe UiTM, near UiTM, you will see actually quite a number of charging stations. These are public charging stations. I would say last year, the number is only 450. And you can see that 1 year, just within 1 year, the public charging station have actually doubled. It's 100% growth rate. So it's a very interesting time ahead for mobility transport market, because they are undergoing the electrification trend, where people are slowly start to change their way of driving to become more environmental friendly and to emit less carbon into the market. Okay, energy efficiency. Just now the previous speaker had mentioned about the processes in palm oil, in oleochemicals, in biodiesel productions. So all this, if we talk about waste recovery, energy waste recovery, how to optimize your chiller, how to optimize your lightings, all these are part of the energy efficiency, which is very important for a company's journey towards net zero. Vertical farming. Actually, vertical farming is another energy trend that we might have heard of in the market. Vertical farming basically is you grow the veggie unconventionally. Actually, you grow it in a machine or in an indoor space. So why vertical farming is so interesting? Because it is able to replace a conventional farming of 1 acre. Let's say you put 1 container, 1 machine farm, the one that you see in the picture right now. The amount of veggie produced in that container, you will be surprised that actually it can produce the amount of veggie equivalent of 1 acre of land. So as we want to be more environmental friendly in the food production, vertical farming is also one of the trends that which is very, very interesting. These are some of the vertical farming system concept. Green hydrogen. Green hydrogen is a new energy carrier that you will be hearing a lot in the near future. Nowadays, when you talk about storage, we always talk about the grid, the Tenaga National Grid. As the grid become limited in terms of how much renewables it can take, that's where energy carrier, new energy carrier like battery, like green hydrogen will be adopt more and more in 3 to 5 years down the road. With that, I think that's the end of my presentation. So back to you.
All right, thank you so much, Mr. Eddy, for your sharing session. Next, it will be a Q&A session where Dr. Chu will read some of the questions from slide. And therefore, I will pass the floor back to Dr. Chu for the Q&A session.
Hey, thank you, Nani. Thank you, speakers, for the very insightful sharings. So let's see, we have about 5 questions in Slido. Okay, let me start. I think there is one question that is specifically directed for you. How are we supposed to increase the use of solar panels, especially in the residential area, considering that not everyone can afford solar panels?
Okay, thank you, JJ. Interesting question. How can we increase the use of solar panel in residential, considering not everyone can afford solar panels? Yes, you are right. Government is actually trying to come up with tax incentive in the coming budget. At the moment, yes, there's no tax incentive yet. And for those who are interested to put on solar system, the rough capital expenditure that you need to fork out is, there's no a ballpark figure around 30,000 to 40,000. So it's actually that kind of amount that anyone who interested, you need to spend that amount if you want to go for solar. However, there's a lot of solar companies that tried to offer, we call it a leasing model. Leasing is like how you lease the cuckoo machine, the water drinking machine. So you also pay, you actually paid a subscription. You don't have to pay upfront cost. Maybe you sign a contract of 3 years with the water company, then you can get the machine over 3 years. Or even the coffee machine. Recently, I also saw Nespresso maybe offer that kind of services. So solar companies, we are also moving towards that direction. My company didn't offer that, unfortunately, because of different business model. However, there are other companies out there that offer you this kind of package where you pay maybe 600 ringgit per month or 500 ringgit per month over 3 years. and you don't have to fork out the 30,000 or 40,000 upfront to install the solar panels. Hope I answered your question.
Thank you. Yeah, that is indeed a very attractive options. It allows a majority of the population to actually afford something that is supporting the green initiative. So thank you for actually enlightening us on these possible options. So to the audience who actually posted these questions, hopefully this allows you to explore a little bit further if you're considering solar energy at your homestay area. Okay, next question, I would like to actually invite Ms. Rachel and Mr. Karthi to chip in. It's regarding the sustainability journey in Malaysia. It has started for more than 10 years, but today we're still talking about it. So perhaps you can enlighten us where Malaysia is positioned now internationally in comparison to where we were before pandemic. So we can start with Ms. Rachel, then Mr. Karthi.
Okay, maybe I'll just talk about it for a bit. I think the pandemic has actually set back a lot of things in terms of economically, in terms of our carbon, our effort in reducing our carbon. Because from my perspective is that in terms of biodiesel implementation of injecting more biodiesel in our diesel, actually we have been talking about B20, 20% of biodiesel blending into conventional diesel. I think starting from, it should be, the previous target was 2019, end of 2019,
Correct,
but then
correct.
till now, the effort is still ongoing. We're still stuck with
Yeah.
B10, which is 10%. So in terms of our, I don't know what is our international position now, but then if we are going to compare pre-pandemic, I think we are actually have a really setback in terms of, because our funding had been mostly contributed to the COVID situation and then stuff like that. So we are slowly catching up. Hopefully that by the end of this year, now it's already mid of the year. So hopefully by the end of this year or next year, we will see much more effort in trying to redo all this in terms of carbon emission reduction effort. It's not only on the carbon, but in terms of every single usage of our utilities, in terms of water footprint and stuff like that. The government might be intensifying in that terms. Yep. But the only conclusion that I can give is that we are actually pretty set back here if we are comparing to pre-COVID. Yep.
Thank you, Ms. Rachel. Mr. Karthi, over to you. Perhaps you need to unmute your mic, Mr. Karthi.
Yeah. So I just checked the figure. Actually, I don't know the figure of the position of Malaysia in the global position of Malaysia in this sustainability development goal. But indeed, in the past 3-4 years, there is a bit of setback, like Rachel said. But, we are slipped around 18 position, I think. To be more specific, we are split from ranking of 54 to 72 in this past 3 years, actually. So yeah, but there is a continuous development, and there are goals set, and there are targets set which needs to be achieved, I think, by the year of 2020. I think this all started in 2014. There is a continuous development, but this ranking slipping, maybe I think maybe also due to the additional efforts of other countries. So though the position is, there is a setback in the position, I think the development are continuous, and we should be achieving the goals by the time. Yes.
Okay, thank you. Seems like the initiative related to monetization is rather important. So let's shift the discussion a little bit to carbon tax. So from my understanding, carbon tax is a fee imposed on business and individual that work as sort of a pollution tax, supposed to incentivize producers and consumers alike to reduce energy use and shift to a lower carbon fuel or renewable energy source. So perhaps next, I would like to invite all our panelists, starting with Mr. Karthi, Ms. Rachel, then Mr. Eddy. What do you foresee as the challenge to carbon tax practice in Malaysia? Coming from an industrial practitioner's perspective.
Again, this carbon tax practice, actually, I don't have much expertise on this. So I will let the other speaker to answer this question. Hello?
Rachel or Eddie? Yep,
Yep.
no problem. Mm.
So carbon tax is quite in Malaysia, to be frankly speaking, we are quite premature. Not just in terms of Malaysia, but in terms of the global situation, that carbon tax, if you are going to the EU country, maybe is much more being discussed about. But then in terms of Malaysia, I think it's our knowledge or our perception towards carbon tax. The idea is not there. So in terms of telling people that actually maybe because the framework is not there, so it's actually the first step is not there. So it's pretty hard. It's pretty hard to just get a kickstart or whatsoever. So yeah, this one maybe we can discuss about it maybe another like 5 years, I guess.
Yeah, when there's a clearer framework, perhaps, right?
Yes.
Okay, no problem. Eddie, what about yours? Do you have any experience perhaps with the EU regions, because they are a bit more mature in terms of carbon tax practice?
I think carbon tax, just to chip in a bit for Malaysia side, right? Carbon tax is carbon pricing, basically. Basically, you price the carbon emissions. In Singapore, they already have the carbon tax last year during COVID time. I think they price it at 20 Sing dollars per metric ton of carbon. Malaysia, of course, we are not ready. And the biggest challenge for carbon tax adoption in Malaysia is obviously the impact to the business and to the people. Because Malaysia, our carbon, our petrol, our diesel are still heavily subsidized. So while we talk about carbon tax, first of all, we have to talk about subsidy first. You need to remove the subsidies, which the government is doing, and they will announce end of the year through the targeted subsidy, which the government is trying to work on. So carbon tax will come, in my opinion, only after the subsidy, targeted subsidy is being removed. Then we will talk about carbon pricing, because if you put a price on the carbon, you will definitely impact the whole supply chain, the whole businesses, the SMEs, and also the people who are also trying to navigate through inflation and all. So we cannot, at the moment, maybe it's not a good time to have the carbon tax.
Thank you for chipping in. There's some questions regarding the carbon dioxide absorption. Perhaps this one I would like to invite Rachel to actually take it. It says that big companies are absorbing carbon dioxide in the open air that may not be produced on site. So small companies might not commit to carbon neutrality. What do you think is your take on the possible resolution to this?
Okay, let me clarify
From
on this
a
question.
practitioners, yeah, can.
So, okay, small companies might not commit to the carbon neutrality. How to resolve? First of all, I think it's our idea, how mature are we in terms of the normal citizens' education in terms of carbon emission. I think maybe we are much more educated in our economic sense that sustainability only appears like 10 or maybe 15 years the most, that it actually is not in the core of our how we think. As a Malaysian, I think our education system is teaching us like how to get more money, but then it doesn't teach us, I don't know what now, but then how to actually achieve a carbon neutrality. But then I will say that every single company or every single individual are responsible for this. We need to start, as most people say, that we need to start by educating. If we don't educate our next generation or ourselves or in terms of carbon neutrality or how we does contribute to carbon emission, I don't think we can resolve it any sooner, except from because including a carbon tax and whatsoever, it's just we are imposing extra cost on things, but then people don't see why are we introducing extra cost on that. So it will, for me, is that it will come back to our perception. Yeah, I think we need to change first our perception before we move on to actually get big companies or small companies or even individuals to actually to contribute on that. Yep, JJ. Back to you.
Yeah, good suggestion. I do agree. Educating the population is important. I think Mr. Karthi has something that he wants to chip in. Karthi, over to you.
Yep. No, I agree with Mr. Rachel that it is a personal responsibility, and the education will help for improving the personal responsibility. But in a country, I think the government policies are much more important. So I believe there should be more focused policies from government towards this, which may force, irrespective of the magnitude of the company, to follow the path towards the reduction in carbon footprint. But also at the same time, it should not be overkill. It should be slow. It cannot be implemented overnight. And those heavy enforcements, big companies can sustain, but small companies can die. So it is a balanced approach that government should take to implement the policies. I think implementing the policies gradually will be the solution for this.
Right, that's a very good one. A gradual implementation rather than a steep change all of a sudden. So perhaps Mr. Karthi, you want to chip in a little bit on the next one. It's about carbon neutrality, which basically refers to the reduction of carbon dioxide only, right? But climate neutrality actually accounts for also the reduction of all other greenhouse gases emission, including methane itself, that affects the climate. So which one would it be the priority from, let's say, a practitioner's perspective?
In my opinion, the carbon dioxide contributes to the majority of the greenhouse gases. I think 70 to 80% around something. So naturally, focusing on the carbon dioxide get much more attention because of the quantity and the percentage of it among the other greenhouse gases. But there are also the importance, like in yesterday's discussion, one of the gentlemen said that capturing the other gases will have economic importance, like conservation of methane is a fuel actually. So that in that aspect it gains importance, but it comes down to the volume. We can take all the efforts to capture the methane, but how much we are capturing, and with that captured volume, what we are going to do. So that is the thing. So in general, the focus is towards carbon dioxide because primarily because of the percentage of it among the other gases. This is my point of opinion in this. Thank you.
True. Eddy, do you want to chip in perhaps on this carbon neutrality versus climate neutrality?
I think carbon neutrality versus climate neutrality, most of the time, I think a lot of people confuse with the two different terms. I think especially in our industry, like even in solar or even in clean energy industry, a lot of people are confused. When they talk about carbon neutrality, actually they are referring to climate neutrality. And when they talk about net zero, they actually are referring to carbon neutrality. So I would say at the end of the day, all the industry, they want to have net zero, meaning to say not just eliminate carbon dioxide, but they also have a huge intention and goal to reduce all other GHG related emissions like methane. So for me, I think all are priority as long as it reduce and save the planet.
Thank you. Let's see. There's one that I think we will have Eddy to take first, and then we will follow with Rachel and Karthi. Is vertical farming produce food considered an artificial food? How could so many food be produced in a small space in its natural way?
Okay, interesting. First of all, vertical farming is a method of farming. It's not an artificial food, because artificial food, we are talking about the food, maybe the processing method, or you are talking about the raw ingredients that you use, right? But here it's different. We are not talking about the raw ingredients. We are not talking about how you process the food. We are talking about the way you do the farming. So conventionally is you put it on the soil, you grow your fruits, your veggies, right? Here different, because instead of growing on the soil, we stack it out. Just now you saw one of the picture, we stack it out. And how do we do that? We don't use soil, because if you use soil, maybe it's not feasible to do that. we use hydroponic system. Hydroponic system is basically the water irrigation systems. So we design in a way that the water will have all the nutrients for the veggie, and we design the racks accordingly that we can optimize the production of the veggies. So to your question, we produce in a, I would say in a natural way, yes, because we don't use pesticide. We even use less water compared to conventional. We use less soil, less space. So in that sense, it's 100% natural. And yes, you will be surprised that vertical farming can produce a lot of food in a very small space. And that's the beauty of it.
Thank you. Yeah, perhaps Karthi, you want to chip in from a consumer's perspective about vertical farming?
Yes, I agree with Mr. Eddy that it's not an artificial way of making food. It is a natural way of making food. And in consumer point of view, this can open up to many. Actually, this can open up to many opportunities and options. Actually, the urbanization is growing now, right? So there are as we proceed, there are less. The space available for farming is decreasing, and also being a farmer, my background is agriculture, so there are a huge number of factors which contribute to the output and yield of a farming actually. So this vertical farming is really attractive because it consumes less water, and the environment required for the farming is more comfortable than the natural, like the open environment available in the farm, I can say.
Environment.
Yeah. So definitely this will result in a higher yield actually, and a higher yield and lesser space. Definitely, if it is promoted in a large way. Okay, now we don't know how in which volume it is being done, but if it is done in a very large way, definitely it can lead to a decrease in price, or it can make available more quantity of food. So it is always a welcoming thing in consumer point of view, this form of farming. Yes.
Good one. So it is basically, to reiterate, it's a change of the method that we actually plant the food. The food that we are getting is still the conventional vegetables or foods that we are familiar with. It's produced in a more controlled environment, therefore there's opportunities for more yield to be harvested from the same investment, and there's possibility to actually reduce the cost of the food. So in some way, it is actually going to work very well as we have more and more population growing around the world. So thank you on the take. There's one question that just came out, Rachel. I think this is for you. It says biodiesel may usually be sourced from waste oil. Could it be produced from any other materials other than just plants and biomass? So perhaps Rachel, you can take the first take, then Karthi can chip in.
Yep. Actually, yeah. Then there is a discussion. I think if you have been studying about the biodiesel process from uni, I think we have a first generation, second generation, and third generation biodiesel production, which from first generation will be based on food source, the second generation based on waste and all stuff like that. And then the third generation will be the interesting one, which will be mostly based on algae. But then it's also a living creature. It's also plants based. I think, yeah, the cell wall is there, then stuff like that is there. So it's also but the problem with the third generation biodiesel production sense of view is that for now it's still too energy intensive to actually extract the quantity that we are producing now from first generation or second generation feedstock. Now even with waste oil, for the trend now is used cooking oil. ICC, they are discussing about there's a lot of double counting which people use other sources, the first generation, to blend into the waste oil, and then to use that credit to actually sell it as biodiesel. So there's controversial going on, I would say.
Yeah.
But then other than first generation, second generation, the only way that people are looking at will be based on algae. So I hope that does answer the question.
Is there any oils other than from plant-based? Is there any possibility to generate biodiesel from perhaps an animal source oil?
That one will also be categorized under first generation, first or second generation biodiesel. Yeah, from lard oil, from beef tallow and stuff like that. Yeah, Karthi? Sorry.
Karthi? Yeah.
Sorry for interrupting. I thought it's for me.
Yeah, no problem.
The animal fats, tallow, and the byproducts of the edible oil processing like PFAD, stearin. So these are the other sources. Apart from this, in my knowledge, there are no other sources. Yeah.
Okay, so the answer is yes, it is possible, as long as you have an oil source, right? Carrying forward from Rachel's discussion about the third generation using algae, the challenge is still the energy intensity tied to this particular source of material, right? There is actually another one which is called the fourth generation biomass source, which is an expansion of algae, where they look at having the algae actually do some carbon capture. So there's some genetically modification to it. There's still some papers out there for the ones who are interested. So that's something that you can explore further as well. Okay, let's see the next one. I think the next one, we can open it up to all the panelists. We can start with Eddy on this. Any scientific data proving sustainability improve financial performance? So it's tied back to dollar and cents. What are the benefits that the public is enjoying from practicing sustainability?
Okay. Scientific data.
Perhaps we can move towards the benefits of the public enjoying from practicing sustainability. Yeah.
Because
I think we
the
can focus
scientific
more on that.
and financial can be on each different opposite ends, right? So but I can answer on that actually because you know that Bursa Malaysia, Bursa, our regulatory for stock market, they're actually trying to get most of the companies comply to ESG. So with that, you can see that actually literally tell us that the financial performance of the stock market of a listed company is actually directly impacted by sustainability. And another point to back up that is also nowadays corporate like us, when we want to raise funds, we want to get bank borrowings, we want to raise sukuk, we want to raise bonds, all required ESG compliance. More and more likely, and banks is stop funding or borrowings to the coal related companies or even stop oil and gas in the next 2 to 3 years. So that shows that sustainability is very important for any company in the current era, for financial especially. Benefits for the public, I would say publics are people like you and me. So yes, I would say it's a no-brainer to practice sustainability. As you can see, Malaysia, we might not face any climate crisis. We haven't announced anything yet. And we are actually in a very unique or in a very blessed spot of the world where we don't have any natural disasters. But if you can hear from other countries, they already have a lot of global warming issues, heat wave. Malaysia also, we also experienced a bit of heat wave lately. Singapore, I heard last week they reached 40 degrees Celsius. So global warming is coming in. Malaysia, we are facing other issues like floods. So all these required sustainability practices from each and every one of us. So I would say super important.
Yep, agree. As global citizens, I think we all benefit from practicing sustainability. Rachel, maybe you can chip in a little bit on, because I know that there are some sustainable practices that's already been undertaken in your company. So perhaps you can share with us some of the immediate benefits that can be seen from the Malaysian scenario.
Sustainability, like what I just mentioned previously, is that in terms of plant optimization, that we can reduce our methanol consumption by 1%. Actually, it does reflect in our dollars and cents, because with that reduction, you can have, let's say, a year of savings around 2 to 3 million RM. So that does obviously improve in terms of financial performance. Another thing will be interesting is in terms of how we look palm oil, the current situation with the EU countries and stuff like that. By quoting us being less sustainable actually does affect our penetration into the market. So if we are going to improve in terms of our performances in terms of sustainability, I think we have a bigger market to just sell our palm oil and just get into through that market itself. So yes, sustainability practicing does improve financial performance, but in terms of scientific, maybe we need to get back to the papers. So the second part of the questions will be benefits that public is enjoying. When we talk about climate change, it's just not about you are feeling hotter, you're feeling heat waves and stuff like that, including that the water disruption. I think every single state in Malaysia are currently facing that. So if we are not practicing, we are not starting to do it. When are we starting to do it? Maybe in the maybe next month or so, we are having another power cut or water disruption and stuff like that. So I think maybe we need to shift our focus is that what can we enjoy from doing so to a focus that if I do so, I'll definitely gain in the future, as in I don't care whether what I do now, what I will enjoy after I do it, but we do it first, then we will come with the enjoy part. Yeah. So back to you, JJ.
Okay, thank you. Mr. Karthi, perhaps you want to chip in a bit on this as well, how the sustainability improves the financial performance, being that Desmet is a service provider, engineering service provider, solution provider.
Yeah, the sustainability and financial performance is actually opposite terms, but we can improve the financial performance by innovation and increasing the efficiency of operation, implementing new methods. This is the way. Continuous improvement is the only way to achieve financial success and maintaining the sustainability. And surprisingly, in some cases, trying to attain sustainability, in fact, we can also really gain financial also. One example is the calculation what I showed in this chemical consumption, and there is indeed everything comes with the capital investment, but we need to look at the longer term and how long it takes to pay back and all those things. So that is my view on sustainability versus financial performance. And public enjoying the benefits of sustainability is that in my opinion, in our childhood we would have been lived in an environment, and now at present, after 20 years, 30 years, we are living in an environment and we practically see the difference in this environment. How the water was before 30 years and how the climate was before 30 years. So it's not like enjoying. So if you want what we had 30 years back, then definitely practicing the sustainability will help us to at least maintain what we have now. So we know in 30 years it has changed like this, and next 30 years what can happen, we cannot even imagine if it continues to go like this. So to at least to maintain what we have now, it is important to follow this sustainability practice.
I cannot resonate anything less. I would say we are a very lucky generation that we get to see what is the changes across time, being the fact that we have experienced what it was like previously running around and all, with enjoying the very nice water and all. So we do want to leave a planet that is going to be at least as is or better for the next generation. Okay, regarding the rest of the questions, perhaps we will answer this in a different avenue. We're getting close to the end of our time together. Actually, we're sharp on the dot, 12 o'clock. Okay, so I would like to first thank the panelists for their very generous sharing and very engaging discussion on the questions posted by our audience. So we have covered in today's session opportunities that can be found in carbon footprint reduction, the initiatives done from the academic perspective shared by Prof. Dominic via a case study, and then the commitment from the industrial practitioners, example like from Malaysia's institution, to actually promote and implement sustainable practices in manufacturing sector. And then the contribution, of course, from the engineering solution providers in developing technology, resources, and equipment that can help to lower carbon footprint. So from Mr. Karthi as well as from Mr. Eddy. So this would, I hope that from today's sessions, our audience have gained a better understanding and new knowledge into the carbon footprint reduction initiative and practices that are being done here in Malaysia across industries as well as the palm oil industry in specific. So of course, we look forward to you graduating and becoming chemical engineers that will join us in these initiatives. Okay, so thank you everyone for coming today. So with that, I'll pass the floor back to our MC. Nani, back to you.
All right. Thank you so much, Dr. Chiu and the rest of the speakers for participating in the Q&A session. Therefore, we extend our heartfelt thanks to Professor Insinyur Dr. Dominic Fu, Mr. Karthi Subramaniam, Ms. Rachel Chok, and Mr. Eddy Lee for sharing their valuable insights and expertise with us today. We would also like to express our sincere gratitude to Insinyur Dr. Chiu, the chair of today's session. And therefore, before we have our break, I humbly request for all of the participants and also our organizing committees to turn on your cameras as we are about to have a photo session. I will be leaving the floor to Yuzari, our technical team, to take charge for the photo session.
Hello everyone and good morning. My name is Muhammad Yuzari and I will be your photographer for today. But to make it more even special, I need everyone help here. So would you mind taking a moment to open up your camera? Participant can locate the camera icon or camera setting of your Zoom video conference and kindly enable it. So I hope everyone can turn on their camera. Our photo session will be around a minute to give time for our participant to get ready. Can you stop sharing video, Hasib? Okay, I will start our photo session now. So please get ready, everyone. 1, 2, 3, smile. Okay, freestyle. 1, 2, 3, freestyle. Okay, that's all from me, and I will pass back to the MC, Nan. Thank you.
All right, thank you, Yuzari, for the beautiful pictures. Therefore, before we have our break, please fill in the attendance form provided in the chat box below, and you can also scan the QR code on the slides. And for the participants attendance form, we will provide it in the WhatsApp group soon. Now, we will be having a lunch break. See you guys soon at 2 p.m. Enjoy your meals.
Thank you. Have a good weekend.
Thank you, everyone. Thank you, speakers.
Everyone, thank you. Bye-bye.
Thank you, everyone.